All right, so off we go. All right, a little bit of a strange lecture today. It doesn't really have enough slides in it. Okay, I'll make note of it and I'll make it longer next time. Okay, so what we do is we take it as a win. In other words, I hope that we're kind of done somewhat quick. Anyway, we see what we can do. Okay, so I got a few things that I'll bring up. It's a good time because this way we've got a few things that we can do. All right, so first thing up is I received a message today, which is really shocking. It says that we can't use this room on Wednesday, and I'm shocked because usually I only find out when I try to come in. So 2 days notice, that's excellent. Wednesday, yes, we have a class, but our class will not be here. We'll have to resort to pandemic time Zoom calls. All right, so that's what we're going to do. I'll let you know what's going to happen about attendance when I get to the actual meeting. I will make sure to replace this item here with a link to a Zoom item. I just haven't had a chance since I got the message. Okay, so that'll be Wednesday, so something different. Okay, it's one of these things, I hope it doesn't happen too often. I don't mind occasionally, and I don't mind if they tell me in advance. All right, so here we go. We've got Lecture 14, Working with Dictionaries. As I said in the news item, it's kind of a repeat of stuff that we've already done, but you know, it's been so long since we looked at dictionaries. I mean, it was before the review last week, which was before the break that we had, so I imagine most of our stuff is probably gone, so I'll have to do a little bit of this. But you can see there's really only like 3 slides. So yeah, it's not going to take long. I'll try to expand it out so at least I've got a few good things, and I've got some examples we'll work through. It may be similar examples to what we did last time. All right, and hey, since we're here, there's always, midterm, okay, because I have had some students asking me already, can we come take a look at the midterm? The answer is sure, just please give us another day or two. Okay, but I promise within 2 days, I will tell the instructors to make sure that the questions along with the instructor feedback are available, and you can take a look and see how you did, where your problems were, and if you have some concerns because maybe you don't think that it was graded properly, then please bring that up with your lab instructor, okay? Don't come and ask me. I will refer you to the lab instructor. So if I'm your lab instructor, yes, you can come and see me, but otherwise, please deal with them. I don't like to get involved with adjusting grades on anybody. I would rather that things be dealt with first. If there's some kind of an issue and it just can't be fixed, then fine, come and talk to me about it. But so just please, not today. Probably not tomorrow, but definitely by Wednesday it'll be available. The reason why is because everybody's buried with administrative overhead trying to get grades put together, and the last thing I want to do is to send like 100 students saying, hey, could you show me the test? Just please give us a couple of days. I promise you will get access to all of this, okay? Just take a bit of time. Okay, since we're here, let's solve a small problem. Okay, fun problem? Maybe a fun problem. Nothing to do with dictionaries yet, but just some lists. So here we go. Some test scores. Yeah, I know I really push a lot of test scores. Okay, here we go. And no, these are not necessarily the test scores that we saw. I'm just randomly typing some things in here. Let's see, an 85. Okay, how many have I got? I got 6 of them so far. 7, 8, 9. And okay, somebody can have 100. All right, let me break this up onto a couple of lines so that we can see them all without having to scroll back and forth. Okay, not a trick question. Let's write down a couple of things, or at least identify a couple of things. How many test scores do I have? Okay, good. I was hoping for 10. Okay, good. I have 10 test scores. All right, how many of these test scores are passes? 7, okay. So there are 7 of them, and I might believe that because, okay, if I count the failures, that's 1, that's 2, that's 3. There's 3 failures, so there must be 7 of them that are passes. All right, so 7 out of 10 people passed the test. What percentage is that? No, that's not percentage, but you're right, that is a float representation of a percentage, 70%, if you were to actually say it. And yes, exactly 0.7. How do you calculate that? Yeah, 7 divided by 10. It's the number of things that are good versus the total number of things. All right, let's write a function for this to find out what the percentage happens to be. I hope you're getting the idea about why I'm doing this as an example. So let's call this the pass rate. okay, because what that is, that would be the number of things. In order to calculate the pass rate, obviously I need the score data, so I'm just going to call it scores, okay, and I'm just going to do a print. Yeah, you've seen me do it before, just temporary, just to make sure everything is working, and I'm going to say print pass rate. I'm going to pass in the test scores. All right, and here we go, blah, none. Okay, everything is up and running. Nothing works, but at least it runs. All right, so let's solve the problem. Now, if you wanted to figure out how many things you have in here that are passes, there's a couple of different ways how to do it. There is a function called count, but that counts specific things. But instead, what you might want is you can just set up a loop and figure out how many things happen to match your category. Or you can use another kind of clever technique, which is, let's have it, we'll call it the pass list. And this is going to be a list of the scores where people have passed. All right, so what I'm going to do is I'm just going to go through all of the scores. So for S in scores, I'm going to ask, well, first of all, I'm just going to print S, okay, because you've seen me do this before. Oh, and now I've undone it. Okay, for S in scores, print S. Okay, hit my fingers in the right spot. There we go. We're seeing all of them. I'm not interested in all of them. I'm probably only interested in scores that are, well, for passes, bigger than or equal to 60, right? All right, so here we go. There's all of the passes. There are 7 of them, okay, and that's kind of part of our number, but I want to count how many I've got. And then I'm going to make things just a little bit more flexible. All right, so how do we count things? Well, there's a couple of ways. You could put a counter in here and say counter is equal to counter plus 1, or the pass count is equal to pass count plus 1. That's completely fine. That's completely legitimate. Or there's an alternative, which I could say pass list append S. Because if I come down here and I show you what's inside S, oh, sorry, not S, pass list. If I show you now what's inside the pass list, what do I have? Well, I have exactly the scores that are passes. All right, so now let's turn it into a percentage. Okay, so instead of printing the pass list, how do you calculate the percentage? Well, how do we calculate the percentage? You get the number of students in the pass list. That is spelled LEN. And you would divide that by how many things total? Okay, how many things do I have total? 10, but to make it more generic, the length of scores. There we go, 0.7. Good, that was the answer somebody said, except I said, well, okay, it's a decimal representation. If you really want it to be 70 instead of 0.7, all we'd have to do is multiply it by 100, okay, 70.0, and maybe if we want it to be turned into an integer, we could probably cast it as an int. Okay, there you go, there's a 70. Now, let's make my function just a little bit more flexible. Instead of asking just for passes, why don't we ask for how many scores are between a range? All right, in other words, what I'm going to do is I'm going to pass in, say, a low and a high, not a height. And really, when I'm asking for the pass rate, I would say, well, please give me everything from 60 to 100. Because, well, you never know, maybe we change it. Maybe we change the pass rate from 50 to 60 or 60 to 50 or some other number. All right, and all that I would need to do is instead of saying that S is bigger than or equal to this, you'd have to say, well, S is bigger than or equal to this, and S is less than or equal to, well, whatever the second value is. And I suppose kind of the quickest way how to do this is to ask if low is less than or equal to S, which is less than or equal to high. It's one little kind of cool shortcut that we've got. In the world of Python. It doesn't work in a lot of other languages, but it is one thing. So in other words, what I'm calculating here, oh, and of course we shouldn't be printing it. We've already learned that what we should be doing is we should be returning values. So let's return instead of printing blah. Here we go, so 70. Excellent. So go through this list of items and find the number of items between the two ranges, between low and high, and return it as a percentage. Okay, hopefully you recognize that problem. That, of course, was one of the programming issues that we had on the midterm. Okay, the only thing, it was just masquerading. It wasn't test scores. It was banking credit scores. Still doing the same thing, just slightly different. Just give me a second while I pop open the second problem, because I can't remember the exact, well, I know the problem, I just can't remember the exact example, so I'd rather grab one of those. assuming I have networks. Okay, I do have a network. And I got to look at the right section, so sorry. Here we go. infs1201, section 2. Okay, almost there. Okay, here, I'll just drag this one over and I can copy stuff as required. Okay, here we go. So some crazy professor keeps all their test scores in a list, but to make sure that no grades have been modified along the way, they add the average in the second to the last position, and they put the sum of everything in the very last position. This type of approach, by the way, is exactly the type of thing that happens. You've actually done it a whole pile of times before, because I'm assuming that everybody in this room has used the internet at least once, for obvious reasons. All right, and yes, every time that a packet goes across the network, what the network does is it actually adds a sum. They don't have it as a sum. They do some other funny things with it. They don't keep an average, but they do some other weird calculations. And basically, the packet goes through along with something that's called a checksum. And what happens at the other side is the network card picks it up and looks at all the data, adds it up in a certain way, and if it adds up to the right value at the end, we say it's a good packet. Otherwise, we toss it out. Okay, that's the way how these things work. Oh, and if you're saying no, but I'm a banking fintech student, I wouldn't know this as a problem. Actually, you guys have this as well. Credit card numbers have to add up a certain way. You can't just have random arbitrary credit card numbers. The very last digit in a credit card or debit card is always a combination of all of the other numbers. In this way, if somebody types in like an ID card for a bank, it can actually tell you that that's not valid. So if you ever go to a website and you type in your credit card number, it says it's wrong, that's how it knows, because the digits don't add up the right way. It does the same thing. Okay, I thought about using digits, and in the end, the calculation is a bit too weird. I figured sums and averages, that's pretty straightforward. Okay, so here we go. We've got this thing called a midterm. So let me grab this one, and we'll come over here. And we'll basically ask the question, is that a good set? And the idea is that is supposed to be a good set. Supposedly, if we were to take these items right here and add them up, I should get 384. And if I calculate their average, truncate it down to an integer. Okay, so just floor type calculation. Rounding, well, the examples here would have been pretty clear. We didn't need to do a rounding. But trust me, if you did that instead of a truncation, that was not the end of the score for you. So all we need to do is, of course, to figure out how to do this. Okay, now I suppose what I could do is I could write a function, because that's what the question asked for, but let me do this without a function. Okay, but trust me, putting it into a function wouldn't be too much work afterwards. Now, you see, the issue is that although it says midterm, it isn't actually the midterm, it's actually midterm data, because it's the midterm scores plus these extra pieces of information at the end to make sure that nothing has been tampered with. Okay, so I'll just call it midterm data. All right, the midterm scores. Okay, well, here, we'll just call it test scores. Where are the test scores? Well, they're here in the list. Yeah, but which part of the list? Okay, 1, 2, 3, 4, 5, 6, 7. I think I've got 7 scores in here. How many test scores are there? How many? 5, yeah, there's 5. Okay. Oh, well, how do you extract out the first 5 things? Well, you would go to midterm data and you'd say, hey, you know, if I go from 0 up until 5 and print test scores, okay, there you go, there's the first 5. This is not a good solution, but it is a start. Some people did this, and no, you did not get a really great score for it, because it didn't say anywhere in the question there's only 5 scores. That was just one example. Because remember, if you go in and you add an extra value in here, that's no longer the midterm scores. Okay, because, well, I'm only picking up the first 5. To pick up everything, well, go until -2. You know, that's what list slicing is all about. Go and extract the first things, but exclude the last 2. Now, for this whole thing to work, My scores are not going to work unless I do this. Okay, that's a much better solution than hard coding at the 5 because now it will work for any length. All right, so there we go. There's the midterm scores. All right, we have, of course, what I'm going to call the stored sum. The stored sum is the number that's inside the list where you add everything up. So where is that located? Well, it's in midterm data. At what position? Where's the sum? Yeah, the very last one. You know it's the last one. Oh, 7. Should you type it as 7?
-1.
Yeah, -1 because that will always work. Okay, so let me write this as stored sum just to make sure we've got it. Yeah, there we go. So there's the list, the scores. We've got the stored sum printed. All right, next one up. We have the stored average. And I saw students call it different words. It's fine. I didn't really go too crazy on these. This would be midterm data at which position? Yeah, -2. It's the second from the end.
Yeah.
Okay. All right, let's print the stored average. 76. Okay, good. We've been able to extract these. Next thing up, we need to do some computed values. Okay, so let's have something called the computed sum. So this is what we get when we add all the values off, not the midterm data, because that's everything, including the sum, but it would be the total of all the test scores. Okay, so how do you calculate the total of everything? Yeah, sum, that was at least decent. And if you wrote a loop for it, that's completely fine. I'm surprised that people wrote a loop for it, but that's fine. You didn't lose any marks for it. And that's good, it adds up to the same. It means that I'm part way there. Okay, the final thing, how about the computed AVG? Okay, how do you calculate the average? Well, you take the sum of the test scores and you divide by the length of the test scores. All right, here we go, and we'll print the computed AVG. Okay, and it comes up with 76.8. Oops. Yeah, for whatever reason, they just turned it into an integer and they threw out all the decimal stuff. All right, the only thing that's left now is just to make a decision. In order for this to be correct, the stored sum would have to match the computed sum, and the stored average should have to match the computed average. If both of those conditions are true, you've got it. You could certainly do this as a whole bunch of if statements, and that's completely fine. You don't lose any marks for this. But really what I'm asking is the computed average equal to the stored average, and is the computed sum equal to the stored sum? And sorry, this is going to go off the edge. Okay, I've got too many. There we go. So in this case, yeah, it's fine. If the data had been corrupted because somebody added a grade because they wanted to have a rounded, or sorry, not that far, wanted to have a rounded off value because it's a letter grade thing, yeah, that would be considered false because now the stored sum and the averages don't match. Okay, the only thing really left to do is to take this, put it into a function. Okay, I mean, if you want, I can do that, but it's just one line, of course, with the doc string and so on. I do exactly the same thing. I don't put the print statements and I just return. Okay, all right, so there we go. They weren't really far, but I know, I completely understand. You know, you've done the practice. I've had some people talk to me already. It's like, yeah, I did lots of practice. I did this, and as soon as I got to this test, suddenly it's just like, whoa. That's why I said it's, you can't just practice the stuff that we give. You really have to work on a lot of it, because the more stuff of this that you do, the more problems that you will end up seeing, the more techniques you'll end up kind of saying, oh, right, there's a cool idea. I can use list slicing for this. This is what I was saying, that you need an enormous amount of practice, probably more than a lot of other courses. And sorry about that. I'll just be completely honest about this. All right. Next thing that I'm getting people asking is like, oh, should I abandon ship now at this point? Ultimately, I can't advise without looking at a very close detail about what you've done. However, I will tell you the following. Is it possible to come back from a low score in the midterm and still do well in the course? Yes, it is. I've had cases where that's happened. Okay, that doesn't mean that, oh, maybe it'll just work. No, that happened only because I saw the person completely change what they were doing, and they dedicated what they told me what felt like their life towards this course. Okay, so that's an opinion up to whether or not how much work you need to do, that type of thing. I've also seen people do okay at this point and not do so well over the next couple of assessments. And the reason for that, if you did fine on the MCQs and you didn't do very well on the programming problems, please be reminded that in like 3 or 4 weeks we've got a lab exam and it's only programming problems. Okay, so you will have to, if you didn't do well on the programming problems here, you will have to do a lot of practice to get there. The programming problems, yeah, there will be nested lists, there will be sets and tuples, there will be dictionaries, and there will be combinations of all of those items. Okay, so it's the more challenging thing. The final exam will look almost the same as what you've just been through. Of course, it will involve tracing questions through MCQs and so on. If you did fine on the programming side, you're probably actually pretty good. Okay, what do I mean by fine? Let's say if you got like 16, 17 on the first problem and maybe you pulled off something on the second problem, then you're probably not too bad. My recommendation is just be more careful with the tracing problems, because I did see a couple of cases where the programming wasn't bad, but then the MCQs were just a complete disaster. Just be more careful. Don't rush through them. Okay, in the exam that I invigilated, everybody was definitely finished within 1 hour on the MCQ part, and maybe they just jumped a little too soon. Okay, I mean, you probably didn't need quite the 2 hours or hour and a half. They probably could have used like just one more review. That's my only comment. And I know it's gross because we have to set that up so you can only see the first page and then you have to move on. Okay, just don't be in so much of a rush, but make sure that you leave enough time for the second one, which means half of the time. Okay, so if you finished after a couple of seconds, no problem, because and you know everything is right, fine, go to the next page. But if you've blasted all the way through and it's only been 10 minutes and you're not sure about things, just take some extra time and go through it. Yeah.
We have a lab exam and the final exam.
Yes.
Will the final exam have a writing code section?
Yeah, it'll look almost the same as the midterm.
Okay.
There will probably be the same number of MCQs and same 2 problems. Okay, one easier, one a little more challenging. Okay, yeah.
So you said in the lab exam we're going to have dictionaries also?
Yeah.
So what will we have in the final?
Oh, we still have searching, sorting, and files. Okay, so don't worry, I've got lots of stuff. Okay, there's lots of things in here. Generally, we haven't been covering files very well in the final exam, so I'm hoping to change that because it is one of the objectives out of the course. All right, so let's get over to the real stuff for the day. Okay, and again, if you came in a bit late and missed the first 2 announcements, first of all, the class on Wednesday will be online. Okay, I posted an item, check online for a Zoom link. That's the first thing. Second thing, if you want to see how you've done on your midterm, please take a look on D2L, probably, maybe tomorrow, maybe the day after. Okay, I will make everything available. Well, I'll tell the instructors to make everything available. Sometimes it takes a day or 2 to get everything put in place. Just please be patient with us because we've got like a lot of administrative overhead for the next couple of days. That's why I don't want so many distractions, but I promise everything will be opened up. All right, so off we go, working with dictionaries, back to our regular material. Okay, so working with dictionaries, as I said, there's only 6 slides in total, but of course the first one is the title, the last one's the end, and of course there is a section here which says these are the textbook sections, which means that I really only have 3. Okay, so yeah, really, really short. Let's work through it. I will pull out an example. As I said in the news item, it has been like, 3 weeks since we looked at dictionaries. So it's worthwhile to go back and repeat these. So it's kind of a very quick review today. It's stuff we've actually seen before, and what I need to do is I need to figure out what needs to go in here instead. Wednesday's class is probably a little bit more interesting because we will work through solving some problems using dictionaries, typical things that we end up doing. All right, so let's go and let's get myself a dictionary. So I'll keep it over here so I can make sure that I cover all of the material. So, bit of a review, bit of a usefulness as well. Okay, here we go. Let me copy this. Okay, thank you, ChatGPT, for giving me a list of students. That way I don't have to type them in. All right, so are these students? Well, they kind of look like students. They have ID numbers that kind of look like our ID numbers. The only thing that's a little bit strange is the ID numbers are strings. Okay, and that's fine because in a lot of cases, dictionaries end up using strings for keys. Okay, and that's fine. Although, really, for a student ID, it could be an integer. Okay, but whatever, it generated strings, so I'll put up with it. And you can tell that the students in the course happen to be a dictionary because we've got a curly brace, which might mean a set or it might mean a dictionary. But the thing that gives it away as being a dictionary is that I've got something followed by a colon followed by something else. That is a dictionary. The thing before the colon is called the key. The item after the colon is called the value. Okay, so there we go. That's a quick review of this. How many things do I have? Well, quite a few. Well, you can quickly count them. How many do I have? 35. Right, because the first one's already taken. All right, so there's 35 things in here. All right, so all that I'm going to do is, okay, I won't write this as functions today. Okay, although I certainly could. I'll just put it up here. Okay, so first one up, print length, print students. This is really cool. Okay, all that it does is prints the entire dictionary. Very, very useful when you're debugging things and you don't know what you've got. Trust me, I do this all the time, print a dictionary. It's not good as an output because usually when I'm running things, I want some kind of a final answer, like, hey, give me a list of students or so on. I don't want to see like a bunch of ugly looking dictionaries. I want to format it nicely, but okay, you know what? This is really helpful because you can see everything. And if you say, yeah, but that's obvious, yeah. Take a course, if you continue on in the INFS program or DSAI, I don't think Cyber does, or software engineering, you'll take a course called Data Structures and Algorithm Analysis. And in that course, we use Java. In Java, if you try to print out the equivalent of a dictionary, it doesn't work. Okay, you can't print these types of things. You have to print the individual things. So this is actually really nice that we've got this. Very useful when you're debugging. Not good for output, but really good for debugging. All right, the length. Okay, the length of a dictionary, it's kind of exactly what we think it's going to be, which is the number of items that are in the dictionary. But the question is, how many items do I have in a dictionary? All right, we just said that there must be 35. Okay, there are 35 students. So my question is, if I run this, do I see 35 or do I see 70?
35.
And the reason why I say 70 is because sometimes people might think, oh, when I'm counting, I count this is one item and this is one item. Okay, that's the reason why it's here. And there will be a tracing question that will try to trick you into this. Okay, the right answer, by the way, is there's 35. Because there are 35 entries in the dictionary. Okay, there are 35 keys and 35 values. So there are 35 things.
Yeah.
Okay, so when you count the length, it's that number. Okay, all right, so here we go. That's the first thing. All right, next thing up. Okay, can we find the minimum of a dictionary? I have no idea what that means. I mean, like, what are we talking about? Are we talking about like the smallest student ID? Are we talking about the name that would show up first in the alphabetical order, or are we talking about the GPA? Oh, okay, well, maybe it just doesn't work at all. Hey, you know what? Best thing you can do, let's give it a shot. I mean, does this even work? And the answer is, yeah, it actually kind of does. It's a little weird. Okay, it came up with 603011111. Now, very nicely, what happened was ChatGPT didn't quite do it nicely for me because they just started adding some extra things on line number 7. I think I gave the first 6 and said, give me another 25 of them or 30 of them. All right, and if you take a look at all of the IDs, you'll notice that this one right here happens to be the smallest. Yeah, okay, so if you ask for a minimum of a dictionary, you'll get the smallest key. And if you ask for the maximum, you'll get the biggest one. If you ask for sum, well, chances are you'll probably get the sum of the keys. I guess we could try that afterwards to see what happens, but I don't want to mess things up. If I try summing this right now, this is definitely not going to work because it's a string. Okay, so there you go. So it says, yeah, you can't combine them together. Okay, yeah, it's the same thing. Like if you have a list of strings, the same thing, you can't apply these. All right, these functions about min, max, and sum for dictionaries, you can do them. Are they useful? Not very often. I can't really think of any reason why I would ever want to find the smallest key, the biggest key, or the sum of the keys if they were integers. Okay, so although we can do it, I don't really see the point. But that doesn't mean no points exist. It just means I can't see the point of it. All right, so that's fine. Those are some built-in functions that we've seen before. What I'm really interested in today has to do with processing these things, especially if we're looking for things. Okay, and here we go. Let's process things. We've been through these types of things before. For example, hey, for in students print X. And of course, you know, the reason why I picked X is because I don't really know what it is yet.
Yeah.
I shouldn't use the variable X because you know the difference. If you write a variable called X versus writing like student name makes your code a lot easier to understand, a lot easier to write. So just for fun, because I don't know what else to call it, I'll print X. All right, we've been able to use the for in structure with sets, lists, and tuples. Okay, with lists and tuples, they worked exactly the same way. We would see each of the values that were stored inside those structures in exactly the order that they were put in. Well, sorry, the order that they were stored. A set was a little bit funny because there was no guarantee of the order, so things could be different, but you would see all of the values. Okay, we just didn't know which order they were going to be showing up in. All right, now the question is, oh, and by the way, yeah, most collections in Python do support the for in structure. So yes, there are more data structures we haven't seen, but they almost always support this for in structure. Let's take a look and see what happens when we run it. And the answer is yeah, it does show up this way. What do we see?
The keys.
Oh, we see exactly the keys. Is there a guaranteed order? Oh, this is the problem. Okay, the correct answer is no.
Okay.
Unfortunately, if you look at my dictionary, it's exactly in the same order I put them in.
Yeah.
Oh, okay. Unfortunately, once that happens, nobody believes me that there's no guarantee of order, but there isn't a guarantee of order. Okay, trust me, there isn't. You will get lucky in some particular cases. If I start to remove keys from the dictionary and put in other keys, you may find that things look very, very different.
Yeah.
Okay, that's just keep this in mind. There's no guarantee. When it comes down to dealing with trace problems involving sets and dictionaries, if I ever ask what's the output, I can't ask it that way. I have to ask what's the possible outputs, right? Because remember, the order could be different.
Yeah.
And sometimes I've been really nasty and I sometimes will give it as a multi-select question. And it'll say you have to select all that's correct. And you'd have to look for the different combinations where things would actually appear in the dictionary. But of course, there's no guarantee of the order. Okay, yes, it looks like it, but in any case, that's not what I'm interested in. If you do iterate through a dictionary, you will see the keys for the X. So if I really wanted to give this a better name, what I would do is I'd probably call it maybe STID for student ID. Okay, because that might make a little bit more sense. Because then what I could do is I could say, okay, I suppose I could have written this function, but that's all right. I could ask a question like if STID happens to be equal to strings, because all of these things are strings, 60301131, and I'm just going to print the word yes. All right, and what I'm doing here is I'm saying if that student is in the list, I'm going to print yes. So is that student in the list? Or sorry, in the dictionary? And the answer is, yeah, I can see it. It's right here. So therefore, if I run this, it will say this, yes. But if I ask for something like 6040, it won't say anything because it's not there. Yeah, you would normally put this into a function. Maybe the function's called does student exist? And that's the way how you could do this. There's actually much faster ways. Okay, there's actually much, much better ways of doing this. Let me comment this one out because I don't want to get rid of it yet. And I will show you a better way how to find out if something is in a dictionary. You could simply ask if 60401131 is in students. There you go. And it comes back with a false. You can use that in an if statement or while loop or whatever. And if I go and I ask for something that is there, okay, it'll come back with the true. Okay, use that to make your decision. Notice that I don't need to loop. Okay, and that's actually pretty cool. You don't need to loop. All right. However, let's go back to what we have. Okay, and this is one of the cool things about dictionaries. If you have the key, you can actually find things really, really quickly. All right, let me get back to what I was doing before, which was simply printing the student ID. Okay, so there you go. There's all the student IDs. If I also needed to have the name, well, I need to come up with some other way how to get the student information. All right, you see, the student information, well, it's part of the value. So obviously I don't get it as a key. All right, so how do you get one of these things, or how do you get the values? There's a few different ways. So I will work through all of the different ways. You see, I might have student details. Okay, that's going to be the details like the names and the GPA. What I can do is I can go to the student's dictionary and I can say, please give me the student whose key is called STID, which of course is changing each time. And then I could print, say, student details. All right, let's take a look at how the output changes. You see, now I'm printing the key as the first item. The second item is that dictionary of information. Okay, well, maybe I don't want to see this as a dictionary, and I just want to see, say, the student's GPA. I just want to see an ID followed by a student GPA. Well, instead of printing all of the students, well, I could ask just for the GPA column. Okay, there you go. All right, and it's quite often the case that if you have a dictionary where you have a whole bunch of things and you're searching for things, yeah, often I end up using variables. And then if you have a dictionary which contains just the same piece of information, yeah, quite often I would end up just hard coding the dictionary key to say, give me this piece of information. Obviously, if I said student details at name, I'll get the name. What would end up happening if I included details phone? Sorry, it's going off the edge. It doesn't show. Okay, you're right, it doesn't show. It's actually a little bit more forceful. Yeah, it crashes. And it crashes with a key error because there is no phone in any of those student dictionaries. Okay, and that's always the trouble, is if you ask for a key that doesn't exist, you will get a key error. So you really need to check in advance, is the key in the dictionary? If it is, then you can pull out the data. Like for example, okay, none of my students actually have a phone number, but let's go and add one just for fun. Okay, just so you can see how this works. We'll add a phone key. So here we go, 555-54444. All right, so some of the students have a dictionary. Okay, not many. But if I try to run this, I will of course crash because the very first item that I find didn't have one.
Yeah.
Okay, so if you really wanted to see whether or not we got a phone number, here's what I would do. I would ask a question. If the phone was in student details, then what I might say is phone number is equal to student details phone. Otherwise, I might say that phone is maybe NA for not available. And instead of printing out this one, hard coding it, I could say phone. Is that what I called it? Yeah, phone. There we go. Excellent. So it's not available for most things, but the one case where I found it, now I can do it. So I can put in ifs conditions to decide if I'm looking for something and I know that some of the items inside the dictionaries might not have that field. Okay, so it's really not that far off compared to some of the things that we have done. Yeah.
I'm just a little confused about something.
Sure.
Key is the name of the thing that.
Okay, so the key is the thing that appears before the colon. Okay, so this is the key of the main dictionary of students, but then inside each student, I've got another dictionary. Okay, and you'll notice that the dictionary, I've actually got a name and I've got a GPA, and in this case, I also have a phone. Okay, so yes, the keys would be name and GPA. Okay. Oh, now here's an interesting thing. We might as well try this because that's kind of an interesting thing that we bumped into. Here. No, let me do it this way. 60301115. Print ST. All right, so prediction. Hey, this could be like a tracing question. Be like one of my horrible Kahoot questions, actually. All right, what gets printed? Okay, so I left everything up. I just picked it over here because I can see it.
Yeah.
Okay, so what do you think? Are we going to see like the name of the student, their GPA, and their phone number? Yeah, whoever said no is correct. Yeah, there's no student with that ID. Okay, why? Well, we just saw it. Yeah, the key is a string versus an integer. Okay.
Yeah.
Yeah. So you have to be very careful of this because you obviously if this can happen, I probably will end up making it happen. There you go. So there's the individual item. Okay. So that is one student. Oh, what type is it? I just printed it. What type is it? It's a dictionary. Good. If it's a dictionary, that means that I could probably go for x in st print x. Okay, so now let's make a prediction. What will we see when we run this program? Yeah, the keys. What are the keys? Name, GPA, and phone. Good, that's exactly it. Okay, good. Now you're getting the idea about how these things work. Okay, so I used the first index given the key to pull out a student, and then I iterated through. Would I do this very often for things with names? No. Again, that doesn't mean that you can't do it. It's not something that's impossible. But generally, I probably wouldn't set up for loops to iterate through the keys. But that doesn't mean that you never get problems that do it. But they're kind of, I'm going to describe them as mostly rare. Sometimes I find students, even in my third year course, basically doing the same thing. They're not dictionaries because it's a different language, but the same idea. Okay, let me get back to what I had before. For x in students, print x. I'm burning enough time anyway. Maybe we won't be finished early. Don't worry, I'm covering most of the stuff we've got here. All right, if I said for x in students, print x, what do I see? Keys. Okay. All right, there's a couple of extra things because if you're looking for somebody with a certain GPA, like if I wanted all of the students who had a GPA bigger than something, could I use this particular approach? And the answer is yes, I certainly could. I would do just what I did. I would get the student details and I'd ask if the student's GPA was bigger than 3, then print out the student information. Okay, that's fine. But sometimes we want slightly different things. And there is an operation called values. Okay, dot values. So it's the name of the dictionary followed by dot values, and it is a function. Okay, and what this returns, ready for it? Yeah, all the values. That's exactly what it is. Okay, pretty obvious. Okay, so in other words, if you're looking for things like GPAs and you're just looking for the names of students, sometimes this can be useful. Okay, and what would I call this? Well, maybe we'll call it ST details. Okay, because I'm incredibly lazy. And I might ask a question like this. I may say, if the ST details GPA happens to be bigger than 3, then I'll print ST details name spelled this way. There you go. Ooh, close the parentheses. Here we go. There's the names of all the students whose GPA is currently bigger than 3. Okay, yeah, so you can use the dot values for that. That's very, very handy. But the problem is if I need to print both the ID and the name, well, now I can't do it because I only have the values.
Yeah.
I'm missing the key. And if I use the for x in students, I only get the key. Okay, so bit of an unfortunate thing, but here we go. Let me go back. I'll call this x once again. Okay, and just print x. Okay, and we just said that those are the values. All right, I'm going to give you another one. Okay, so for for x in student.keys, what do you think the method called .keys gives you?
The keys.
Yeah, the keys. But we had that already. Yeah, exactly the same. Okay, good. So why do they have both? Well, this is for people who want to type less. This is for people who want to type more, I guess. Okay, it isn't actually necessary. But what it does, it actually returns something. Because the keys happen to be all unique, it basically comes back the same as a set. And you can put them into a set and then do some manipulation on it. So if you get a situation where you're looking just for the keys, but you don't want to iterate, you just want a set of keys, that's actually what you use it for. All right, there's another one, however, that is kind of important. So you don't have to worry about it, but you have to know about it. Here we go. There's a final one called items. And items is actually really quite useful. What it ends up doing is the X is actually, ooh, let's see if you can identify the type. There you go. There is one of the X's. What type is it? Sure it's a dictionary? Yeah, it's a tuple. You can tell from the parentheses. All right, it's a tuple with how many items? Yeah, good. There's two items. There's one comma right here. All right, the very first item in the tuple is this. Well, it is a string. It's the ID, which happens to be, when we talk about the dictionary, it happens to be the keys. And the second item, which is stuff from here to here, those are the dictionary's values, yeah. So it's a key and oh, hey, excellent. So it's got both. So in other words, this is actually a whole lot of information in here, but because it's a tuple, usually this is the way how I would deal with it. I would probably unpack the tuple. You can use it, and you could definitely use x at position 0, x at position 1. I don't like it because it obscures what you're typing. It's better to have variables. But remember, if you have something that sends back a tuple, you can actually give it a tuple up front, and it will take the key and put it in the first item, or sorry, the first variable, and it'll put the value in the second one. So if I wanted to print the ID, it'd be stid, and if I wanted to print the name, well, that's over in the details. And because details is a dictionary, and I've got a name, there you go. There's the ID and the name. So that one is, the dot items is really, really quite handy. It's not, oh, this is the only thing I need. No, you can't say that. It really depends on the problem that you're trying to solve. Okay, it really does depend on the problem. Sometimes you want both, sometimes you only want the key. The downside to this, we don't really get into in the course, but the downside is this would be a little slower, because iterating through the keys, that's probably faster. And then if you find something that you're interested in, maybe at that point, then you go off and you pull up the rest of the data. It's not something, as I say, we deal with in this course. So you could pick one or the other. Nobody will get in trouble for using one approach or the other. But if you're looking for both the keys and the data, or keys and values, sorry, to be more precise, yeah, this is typically the way how we deal with it. Okay, I think that might actually be almost the end. Let me pull up the slides and we'll see what's in here. And if there's anything else, then fine, we'll do it. Okay, so a for loop iterates over the keys by default. Okay, that's what we did the first time. You can use a dictionary with the square brackets and a key to access a value at a particular key. And the dictionary.keys returns a view of all the keys, but as I say, it's not that useful because most of the time people just use a for loop to iterate. But that doesn't mean you can't use it. If you wanted to see only the values, yeah, you'd probably set up a for loop to go through the dot values. It doesn't give you access to the keys, but useful when the keys don't matter. Okay, like for example, if you're going through and you didn't need the ID of the student, it was a really simple thing. Would you save time, or would I take off marks if you went through items? No, not really. But of course, then there's also, if you need both the keys and the values, then the items is kind of the most important thing. It just happens to be that it returns a tuple, and most of the time, tuple unpacking is probably going to be used. Okay, and as I said, boop, that's it. Okay, how much time we got? 2:48. Okay, you give me a second, and we will see if I've got a Kahoot about some dictionaries, and if that's the case, then we'll burn like 10 minutes, and then I think we're pretty good. And this, of course, is only if I get myself logged in. So, because I'm pretty sure I probably have some Kahoot questions about some dictionaries. I just have to remember my password. Not that one. I hope I don't need to reset this password, do I? Yeah, not working well for me. I normally log in advance because I'm expecting, okay, give me a second, let me reset my password. I bet this happens to everybody, doesn't this? But probably in the end, I'm probably just logging in with the wrong username. All right, so give me a second, as long as the reset shows up soon enough. And if it doesn't, then I guess we're so, okay, bad news for you. I got a link. See, this is the issue about passwords, right? And and by the way, if you're cybersecurity students, and you ever end up in an IT organization, please don't make people change their passwords like every 4 or 5 days, because it really becomes annoying and you're probably not actually increasing security. All right, good. So I got myself logged in, and do I have something about dictionaries? Dictionary slides, dictionaries. Okay, I have one thing here with 6 questions. So here, I hope we've gotten enough out of our slides to be able to go through this one. Okay, if it goes really bad, I'll have to switch it off. Okay, so go ahead and join that one. Okay, lots of trouble going on in other courses. Okay, 15, 16. Okay, let's see if we get any more. 17. Okay. All right, you can have a couple more seconds then. A Zinger burger. You're making us feel hungry. Don't do that. What do you think? Zinger burger from KFC or from Hot Chicken? Okay, I think we got enough. Oh, okay. Somebody always waits. Okay, here we go. Start. Bang. Oh, go. All right, so let's see how bad this is. Maybe it's completely impossible questions, but it's all about dictionaries. If it's really bad, then I'll pull it out and we'll do it on Wednesday or next week. Okay, so typical. Let's see output of the program. Oh, yeah, this will be fine. Not great, but it'll be fine. Dot keys returns a set. Dot items returns a list of tuples, and dot values returns a list of values. Okay, we got 19 people, so if 19 people answer, I think it automatically goes, or I will skip it at that point. Okay, so 13 people answered and the other 6 have given up completely. Okay, maybe you're still thinking. How are we doing? Okay, yeah, we'll be finished by 10 after, I think. Okay. Ooh, okay, good. More people got it correct. All right, just as a quick review of this one. Okay, we have a bunch of colors, and if you ever done any web type HTML stuff, you might recognize these. All right, so we got a bunch of colors. There are 4 colors. All right, the very first thing that it does inside the program, it says colors at black is equal to 0. Well, that's a brand new key item. So therefore, now my dictionary has 5 items. All right, on line, the very next line, sorry, I should have numbered these. This one right here, it says that blue is now equal to this. So after doing this, do I have 5 items or do I have 6 items? No, I have 6 items. The reason why I have 6 items, even if you get wrong, you'd probably still get the right answer. It has 6 items now because there is a brand new key called blue as opposed to blue.
Blue and capital.
Yeah, blue and capital. It's a different key because they're strings. So just watch out for that. All right, so then what we do is we figure out the number of keys. Okay, so you know what? Even if you got the wrong answer and you said there's a million keys, or a million items in the dictionary, okay, well, let's say it's 5, even though, okay, it's 6. You'd pull out a set of keys, which would be red, green, blue, cyan, black, and blue. Okay, I'll say it that way. All right, so there are 6 of them. B will be a list of all of the values, which will be, I'm not going to try to say that. Okay, it'll be the 0xFF00000, FF0000, FF00, all of those values. How many will there be? There will be 6 of them. Because there are 6 keys, therefore there must be 6 values. All right, and the final thing is the number of items, because eventually we're calculating this. So remember, items is a bunch of tuples, and how many tuples will there be? There'll be 6. Yeah, each tuple will have 2 things, but there will be 6 of them. All right, so if you take 6 and you add 6, that gives you 12, and you subtract 2 times 6, you get 0. Okay, so that's why it's a 0. Okay, next one. Got piles of time on this one, didn't I? All right, here we go. Okay, oh, it looks like almost the same thing. Of course. Oh, a piece of paper and a pencil would be handy with this one. Okay, 17. So are there still 2 people around, or we've disappeared? I think I got 17 last time. Okay, good. So that was the last one. All right. Ooh. Oh, more people went for 10 rather than 9. Okay, so let's take a look at this. All right, so ultimately what we're doing is we're printing the length of S. S is a set. Remember that a set works like this. If you have duplicates, it basically ignores. Okay, so now what we have to do is we have to figure out what's being tossed into here. And it wasn't just completely obvious. All right, so right here we said go through all of the X's in A. Okay, well, A was a set of keys. All right, so here we go. Red, green, blue, cyan. And what about black? Well, black is a new key that didn't exist, so a new thing got created. So that's what the runtime error was there for, in case somebody thought that. Okay, so there are 5 things. All right, next thing up. So there are 5 things I've added to the set. They're all distinct. Okay, so there are 5 things. There are 5 distinct things. The next thing we're going to do is, in this area, we're going to go through each of the B's, which are the values. So I'm going to toss in the FF00000. I'm going to toss in the F00FF00. I'm going to toss in the 000, and I'm going to toss in the FF00FF. But then there's going to be another one which is all zeros, but it's already there. Okay, so remember in the dictionary this and this were here, so that's why we ended up with 9.
Okay.
Okay, yeah, because it's a set. Oh, that's like incredibly nasty. This one I should have marked as being hard. Okay, and also a little unfair because you don't know how something works. I should have pointed that one out, although you might be able to infer from it. Okay. Ooh, hey, good. More people got that. In that case, we don't have to look at it really carefully. Okay. Just a couple of funny things about this. If you take a dictionary and use a set, I mean, remember, we've been doing this. If you have a list and you apply the set function and you pass in a list, what happens? Well, you get a set. All right. And what things are in the set? Well, all the items that are in the list without the duplicates. If you take a dictionary and turn it into a set, you get the keys. Okay, and yeah, because remember, if you iterate through them, you see the key values. Yeah, so if you ask for a set of a dictionary, you'll end up getting the keys. Okay, so I can, how far, I think, no, it's going to be too hard for me to get out of that and actually bring that up. I was going to do that as an example. So in other words, if I were to take dictionary A, turn it into a set and print it, I would see 1, 2, and 3. Okay, that's what I ended up getting. All right, and the same thing here, this set, this would be 2, 3, and 4. And if you remember what the ampersand is, that's a set intersection. So those are the things that are the same in both. That's why they use the ampersand to remember you and. Okay, so which things are in common? Well, I see the 2 and the 3. Okay, so I see a 2 and 3. And then I ask the question, is K in the dictionary A? Well, of course it is, because it was part of the intersection, so both will be in A. So you'll end up calculating out this way, okay? All right, so that's this one. So it's the 2 and 3. Actually, if you just work out which things are in common, then you know you've got it. It's obviously not a list, okay? Because it's a set, or sorry, a dictionary. Okay, next one up. Oh, okay, well, the good news about this, what does it say? Can you do this? I will not try to convert a set into a dictionary. Okay, what do you think? Do you think you could take, so we know that we can take a dictionary and turn it into a set, and you get the keys. Yeah. What about taking a dictionary and turn it in, or sorry, a set and turn it into a dictionary? Because you can take a set and turn it into a list. You can take a set and turn it into a tuple, but can you turn it into a dictionary? And the answer is no, because remember, dictionaries have key values. This obviously wouldn't work if you had a set of integers. Okay, so not possible. All right, so, all right, 5, 6, okay, hopefully the next two are shorter, easier. Okay, and, no, yeah. Oh, more of these horrible conversions of things. What was I doing? But if you use some intuition, you can actually pull it down pretty quick. Oh, and in case you're worried about this, do I ask questions like this in the final? No, they're never quite like this. Okay, this would be kind of extreme. Taking notes of something to do. Okay, so not that great. So unfortunately, now we have to look at it. If you guys answer answer better, then we don't have to look as close. All right, so what are we doing? Okay, we've got a dictionary X and a dictionary Y get sent up into something, and we are returning a tuple. Okay, unfortunately, all of the possible answers were tuples, so it didn't help. If there's only one tuple, it'd be easy. All right, what we ended up doing was we took the values, which is kind of like a list, and we turned it into a set. But remember what that does, that gets rid of all the duplicates.
Yes.
Okay, so in other words, the dictionary.1.values would be apple, banana, cherry, then we turn it into a set with apple, banana, cherry. Okay, we do the same thing with dictionary 2, grape, date, banana, as a set. All right, so now, of course, what we're doing is we're looking for the things that are in common between them. That's the intersection. All right, so what's in common? Banana. Okay, so here we go. Banana, and banana gets returned, and yeah, there you go. That's a banana. Just a banana, nothing else.
Why not the keys to answer?
Sorry, why not the keys?
Yeah, plus 3 and.
Because I said dot values.
Okay.
Okay, that's why.
Okay.
Now, if I left out the dot values, then you get the keys.
Okay.
Okay? Okay, one final one. Hope it goes quick, then we'll be done. Oh, that's nice and easy. Yeah, sometimes it happens. But I gave it away by giving some useful names. Or maybe I did. Maybe it's just a distractor. Time for that. I'll deal with that afterwards. Okay, if everybody gets perfect, then I don't have to explain anything. We're done. Okay, well, it was more. But in any case, we'll just do a quick little review of this to see what we've got. Okay, here we go. All right, so yeah, we call something with dictionary A and dictionary B. I did something a little bit weird. I switched around what you might expect for the keys and the values. Basically, I'm talking about, well, maybe this person has 3 bananas and 2 bananas and what? Wait a minute, hey, what happens if you have two things with the same value? Oh, great. Maybe this is the one that we have to figure out. Okay, so I better put that away. Okay, let's bring up the bring up this so that we have an answer. Okay, so what can we do here? So let's have a dictionary. Okay, we'll just call it test. All right, very quick thing. Banana, 3. Okay, and cherry, 2. Print test. Nothing funny going on here. All right, so obviously what this is saying is maybe we use it for a shopping cart online and you say the person is buying 3 bananas and 2 cherries or 2 kilos of cherries or whatever. The question then becomes is what happens if somebody sticks another one in and will really make it stand out? Okay, so my question is, okay, possible values. 3, 30, 33, or error. Now, that could be a simple trace question on a final exam. Which one shows up? 3, 30, error, 33, or is there another possibility where maybe it's undetermined? Okay, nobody wants to answer, so I better run it. All right, where's the run? Move that out of the way. Here we go. So go ahead and run it. I came up with 30 and 2. The reason why I came up with 30 is because when it bumped into the second one, it trashed the first value of 3. Okay. Yeah, although there's kind of no real guarantee, this is what I usually end up seeing most interpreters do. This I would never put as a question, because personally I don't think it's reliable to say that, yes, the 30 would be overwritten. Okay, I would never do that. But just to let you know, when you do this, you don't end up with 2 bananas. You don't add the 2 together. You'll end up with just one thing. Usually what I've seen is always the second one, but I don't think in the specs it actually says. Yes? Sorry?
Not supposed the keys be a unique name,
Well, the keys are unique.
but there's 2 bananas.
Yeah, it's 2 bananas, so it got rid of 1. Okay, and it simply kept the second value. And as I say, I don't know if it's part of the spec. I could look it up. I don't know if there's a guarantee that it always takes the second one. I believe it probably does because of the way that it parses. But as I say, I probably wouldn't ask a question like this because that is perhaps a little misleading. All right, where did we go? Let me get back over to here. All right, so what that would be the first thing is you'd have to realize that the first dictionary only had let's see, apple, banana, cherry. Oh, this is all fine, is it? Apple, banana, cherry. Oh, banana. Oh, okay, so that's no problem. Okay, so maybe I had less of an issue. So let's see. We pull out the keys, find the keys that are in common. The keys in common happen to be banana and cherry. And then you go through and you set up the value for banana and cherry. Cherry and banana. Okay, so, all right, so then it's just the question is, did they add them together? Did it merge the 2 together? And, okay, well, let's see if we can figure out what ended up happening here. All right, so we took, here we go. You see, I took the key, I took the value at the given location, but then I turned it into a string. And that was the trick. That's why we end up the string 24 rather than the value 6, okay, which is a really nasty trick. But it was because of the str, okay. All right, yeah. Obviously, you can tell that dictionary tracing questions can be a little more tricky because there can be a lot of stuff involved. Obviously, I have to keep the size of the questions down to something that's not completely out of control. So congratulations for winning absolutely nothing, except that now we're 1 and now we're finished. Okay, excellent. So remember, check the news item for a Zoom link. Don't come to class. Don't worry about tapping your card. I will deal with the attendance in some other weird way. I don't know what I'm going to do yet, but I will do something with attendance.
Lesson.
Okay, see you.